2.6 practice problems, page 69. I'll do some of the evens, not all of them. But that's fine. I should give you enough to go off of. So here we go. Question 2, x equals 4. So we got the absolute value already by itself. So we need to break it up into two equations. One where it's positive and one where it's negative. So that's all we have to do in this case. X equals -4 or 4. And another way we could write that is x equals plus minus 4. That's something you can stow away. X plus minus 4. That's something you can keep for later. Absolute value of x equals -5. So let me ask you, what number can we put into the absolute value sign so that a negative number comes out? What's our rule for the absolute value sign? Whatever's inside of it become positive. So is it possible for it to be negative? No, it's not. No solution for this one. There is no solution because you can't put something into the absolute value and have it come out negative. Negative x equals 0. So it's 0 isn't negative, so we can do it. So let's break it up into two parts. Negative x equals 0 and negative x equals -0. These two things are the same. They both say, well, we can divide by 1 just so you can be sure. But 0 divided by anything is 0, so we've got x equals 0, and then same thing over here, x equals 0. So all it is in this case is x equals 0. That's the only value where we would do 0 coming out. 2/3 x equals 4. 4 is positive, we're good to go. We make two problems, 2/3 x equals 4, and then 2/3 x equals -4. What's happening to x? It's being multiplied by 2/3. How do we undo that? We multiply by the reciprocal, 3/2. We can actually work both these at the same time since it's the same steps. Cancel, 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 cancel. What we do to one side, we'll do to the other. Excuse me. 3/2. Cancel 1, cancel 2. X equals 6 on this side. Multiply by 3/2. Cancel 1, cancel 2. This is a negative. Don't forget about the negative. Negative 2 times 3 equals -6. 6. And we can double check it if you wanted to plug it back in. Alright. 4x minus... Whoa, what's going on here? 4x minus 11. Got to be careful with all those straight lines. But what do you notice? We got a negative. We can't put something into the absolute value and have it out negative, so this is another example of no solution. Alright, we got x times the absolute value of x minus 5 equals 32. Before we can split it, we gotta split our two equations. We gotta get the absolute value by itself. So what's happening right now? It's being multiplied by 8. How do we undo multiplication by 8? We divide by 8. What we do to one side, we'll do to the other. Cancel, cancel. We're left with the absolute value of x minus 5 equals 32 divided by 8 is 4. Now we can split it. X minus 5 equals 4. X minus 5 equals -4. What's happening to x is being subtracted by 5. We undo subtraction by 5 by addition by 5. What we do to one side, we'll do to the other. We got x equals 9 in this case. We got x equals 1 in the other case. Alright, -3. X minus 1 equals -9. You might say, oh, it's negative. But we haven't gotten the absolute value sign by itself yet, so we don't know for sure. What's happening to the absolute value? Being multiplied by -3. How do we undo multiplication by -3? Divide by -3. What we do to one side, we'll do to the other. We're left with x minus 1 on this side. 9 divided by 3 is 3, and our negatives cancel, so we're just left with 3. So that's great. So it's positive, so we can keep going. Split it, x minus 1 equals 3, and then x minus 1 equals -3. What's happening to x? Being subtracted by 1. How do we undo subtraction by 1? We add by 1. What we do to one side, we'll do to the other. Cancel, cancel. We're left with x equals 4. And on this side, we're left with x equals -2. If we plug them back in, we'll see we get the same thing. All right. We got to get absolute value by itself. Right now, it's being subtracted by 7. What we do to one side, we'll do to the other. We're left with 9x plus 6. Absolute value equals 24. Now we can split 9x plus 6 equals 24. 9x plus 6 equals -24. Subtract 6. Cancel. We're left with 9x equals 18. and we're left with 9x equals 30, negative 30. In this case, we got x equal divide by 9, x equals 2, divide by 9, and 30 and 9 have 3's in common, so divide by 3. So we got x equals negative 10 over 3, and x equals 2 in this case. All right, negative absolute value of x minus 3 equals 1. What's happening to x? Being multiplied by negative 1, then subtract by 3. We're undoing everything, so we start with addition, subtraction, undo subtraction by 3 by adding by 3. What we do to one side, we'll do to the other. We are left with negative absolute value of x equals 4. We still got to get x by itself, divide by the negative 1, cancel. Divide what we do to one side, we'll do to the other. 4 divided by 1 is 1, but because of the negative, we got negative 4. Absolute value of x equals negative 4. Uh-oh, that's a problem. The absolute value of anything cannot equal a negative number, so we got another no solution right here. All right, now 1 through 4, we got some more word problems we need to convert into math sentences. Number 2, the total cents for x quarters, y nickels, and z pennies. So for every quarter, how many cents is that? 25. So if we have 1 quarter, we have 25 cents. If we have 2 quarters, we have 50 cents. Nickels, for every nickel, we have 5 cents. And for every penny, we have 1 cent. So we want to know the total number of cents if we have quarters, nickels, and pennies, so we just add them all up. The total number of cents equals 25 times the number of quarters plus 5 times the number of nickels plus the number of pennies you have. Number 4, the difference between twice a number and the number squared. So the difference means subtraction, so the difference between twice a number, which is 2 times a number, and a number, and that numbered squared. Number squared. There we go. Great. All right, 6 and 8 to finish it off. For questions 5 through 8, we're just simplifying. So we want to combine like terms as much as we can. So we're following order of operations still. So first of all, can we do anything inside the parentheses? No, not really. But we can distribute. So let's distribute this 5 through. 5 times b is 5b. 5 times c is 5c. b times 4 is 4b. 4 times negative c is negative 4c. Negative 3 times b is negative 3b. And negative 3 times c is negative 3c. Let's combine like terms using our circle squares. We'll do circles for b's. And squares for c's. Alright, great. Adding up all the b's, we get 5b plus 4b minus 3b, so 6b altogether. And then for c's, we get 5c minus 4c minus 3c, which gives us negative 2c. Great. There is another way we could have done that, but that will be too confusing right now. And now let me do number 8. Okay, once again, we're just going to combine like terms as much as we can, and we're going to simplify as much as we can. So first of all, order of operations, parentheses, can we do anything inside of here? No, we got different variables, so we can't combine them. Parentheses, exponents, yeah, we got exponents, but they're already as simple as they can be. Remember that this square does not apply to the 13, it just applies to our variable here. Now, multiplication division, yes, in the form of our distribution right here. So we're going to distribute our negative sign through. So rewrite everything we're not going to touch. 18z squared plus y squared. Now, negative 1 times 5y squared equals negative 5y squared. And negative 1 times z squared is negative z squared. Basically, whenever we have a negative to distribute through, we're just going to flip the sign of whatever's on the inside. All right, now let's use our circle squares. Squares for y's. Circles for z's. All right, we got 14y squared plus y squared, which gives us 15y squared minus 5y squared, which gives us 10y squared. And then for the z's, negative 13z minus another z squared gives us negative 14z squared. That's it. And yeah. Y'all are doing great out there. Okay, bye.